Okay, guys, and we are back for another video. Welcome. I think today what I want to go over is all the different kinds of bonding that we've covered over the course of these last few weeks together. We've looked in a lot of detail at ionic bonding and covalent bonding, both in these giant covalent structures and these small, tiny covalent molecules. And also we've looked at metallic bonding as well. So we have to be able to understand what each of these different bondings are like and how they are different. And also a lot of questions won't tell you what the bonding is you need to talk about. You have to work out whether or not a compound you're coming across is that specific kind of bonding. So we'll look at a few questions that we'll go across. I think what I'll do is I'll just break down 4 separate videos. So there'll be a different video on each of the 4 different ones. And then at the end, I'll have a little video going over all of the different kinds of bonding and kind of bringing it all together. So let's just really, really quickly do a recap over all the things that you should know about ionic bonding. So here we go, ionic bonding. Right. So, obviously, what I think we should do is just start off with the atoms first. What's going on in terms of the atoms? Then we'll talk about how the atoms come together to make a structure. And then we'll talk about the properties something has because of the structure. So that's really how you should think about this if you're answering questions as well. Talk to me what's happening to the atoms in that kind of bonding. Secondly, how do the atoms then stick together because of that kind of bonding? And then thirdly, right, because of that, the atoms sticking together in that way, what are the properties that it has? So here we go. What happens to the atoms? Well, what we have with ionic bonding is we have atoms will gain or lose electrons to form full outer shells. Now we see this if we have something like sodium fluoride. Sodium is element number 11. You can check that on your periodic table, which means there are 11 electrons in it because it has the number 11 is its atomic number. I've just drawn 10 electrons. This is the 11th electron here. There we go. And if we draw fluorine, fluorine is element number 9. Remember to use dots and crosses. Each element should be a different one. Here we go. 1, 2, 3, 4, 5, 6, 7. You know what? I don't like where I've positioned this. I'm just going to erase that. I'm going to put that extra one over here. No biggie. Right, here we go. I really should draw the circles first. That's actually quite good for me. All right, so here's what's going to happen. So this electron is free, and you can see here there's a bit of a gap. So that electron will jump from there and into that position over there. So what does this end up becoming? I'm going to draw this again in red. So we end up with a sodium atom, but this time it has lost one of its electrons. So on the outside, we have, like this, a full outer shell. Now it's also lost this electron, so it becomes positively charged. The whole thing is positively charged. Right, what does this guy become? So we're going to have fluorine, again, 2 electrons here. And then all of this is going to be exactly the same as it was before. But we're also going to have to include that electron that jumped from the sodium to the fluorine. So if I just draw the shell, I'm getting so much better at drawing these shells, and then put these square brackets in, and obviously this one would be a minus charge there. So this is what happens to the atoms in this situation. Now, where's... Aha, there we go. So, let me just scroll up and let's crack on with the next bit. So now we've got positive and negatively charged particles. Now you should probably know that if I've got a positive particle and a negative particle, then what happens to those things is that they attract each other. So positive and negative particles will attract. Now, because they're attracting, they're going to be very, very strongly stuck together. But you may also know that positive and positive, or negative, these things will repel away from each other. So they do not want to be anywhere near each other. Same charges will repel each other. So because of this, when you're building up a structure of these atoms, it has to be alternating positive, negative, positive, negative, positive, negative, positive, negative. So it's kind of a little bit like this. So we're going to have the negative particles there, and then this negative, negative, negative. That's positive, 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 positive. It's going to be negative, negative, negative. So you end up, let's put all my negatives in, with alternating positive and negative atoms. Now, obviously, I've only drawn this in 2 dimensions. What it is actually like is a 3-dimensional shape, so it extends out into all dimensions, but obviously I'm drawing this on a 2D surface. I'm not very good at drawing in 3D, so I'm not going to attempt it, but you can imagine this stretches out into infinite spaces. Very, very, very large molecule. Now, what's holding these atoms together? So the ions are held together by the electromagnetic force. Remember that word, it will come up. So because the electromagnetic force is so strong, it's holding all of these ions together, and they're really, really, really tightly connected, really, really close. So we're talking high density and very, very strong. This is a strong force. Makes it strong and dense. Now, it takes a lot of energy to break these bonds. So therefore, it has a high melting and boiling point. So you can kind of imagine, if I'm going to melt this, all those particles that are really close together, they're going to start coming away from each other and kind of like breaking apart and start being able to flow around each other if they were to become a liquid. And because this electrostatic force is so strong, you actually require a huge amount of energy to be able to break that bond between them and to allow that to happen. So they have very, very high melting and boiling points. The last thing I really want to talk about is its ability to conduct electricity. Now, as a solid, ionic compounds can't conduct electricity. So ionic compounds can not conduct electricity whilst solid, but they can as a liquid, or if it's dissolved in water. So we've got this idea here that the solid ionic substance is very much stuck together whilst it's a solid. These particles can't move around. They're not free to move. But if it's a liquid, then the particles are free to move. If it's dissolved in water, then the water particles surround the charged particle, and then it can sort of move through the water. It's free to move within the liquid of the water. And so therefore it can conduct electricity in these two positions. Let's elaborate that on that a little bit. So again, let's just, if we imagine our ionic substance, again, I'm not going to put the charges in this time just because I'm lazy and I can't be bothered, but if you're drawing this diagram in your books, you probably should, or if this is even more importantly, if it's an exam, you definitely should. Here, I've got all my little particles. They're very, very much stuck together. Now, to make electricity, electricity needs two things. First thing you need for electricity, you need charge. And the second thing you need for electricity, you need movement, because electricity is a movement of charge. Now, here, these particles are charged. They're ions, so they are charged particles. This means that we've got charge. So the first thing to have electricity, yep, totally. We're here, we've got charge, Brillo pads. Second thing though, do we have movement? No. These particles are stuck where they are. They can only vibrate. They can only sort of like move around around each other like this. They just can vibrate. That's it. So, because solid particles are unable to flow freely, you cannot conduct electricity. Which is, that's the way. We can't conduct electricity here. It's just not possible because these solid particles are stuck. However, if we heat this up and I make it into a liquid, so if heated to a liquid or dissolved, the particles will be free to move and therefore will conduct electricity. So that's it. We've gone through all of ionic bonding. Make sure you click onto the next video so that we can talk about covalent bonding. Have a good day.